Okay, welcome to a new unit, trigonometry. Today we're looking at a video that deals with this handout and will be for days 1 and 2. So fresh new unit, and I find that some students either really love this or can't stand it. So if you pay attention and follow along, I actually do think you'll find it very interesting. There are a lot of great things that you do with trigonometry that you've never been able to do in math before in your academic mathematic career to date. So take a look and keep your mind open and stay positive. So here we go. Fill in the blanks. Congruent shapes have the same shape and size. So they're pretty much exactly the same. The symbol that you see, the symbol that you see here means congruent, and this symbol here means similar. Okay, so we'll be using those throughout the chapter, of course. Our new learning goals are that similar triangles have corresponding angles that are equal, and the ratio of corresponding sides, ratios of corresponding sides that are equal. And we're going to do this on this handout as well. I'll prove both of these learning goals to you. Congruent figures have the same size and shape. Similar figures have the same shape, but they're different sizes. Okay, so let's take a look at that right now. Let's look at our first question. Name the similar triangles. Write the letters so that equal angles appear in corresponding order. You'll notice here that there are symbols for the angles there. Single curve, double curve. Here in this triangle we have a single curve and a double curve. And we have this little, like a degree symbol, for example. All those are indicating that the angle, they're just pairing up the angles. The angles in corresponding triangles are equal. So if we're naming, we know the triangles are similar because their angles are equal. And that tells us this in the learning goals that corresponding angles are equal. In this case, we have two triangles. We have triangle JKL, and we also have triangle. Now, when we're writing these letters, we want to make sure that I'm going to follow in this imaginary. There's an imaginary table here that we're looking at, and I want to make sure that whatever angle is congruent to angle J, I will put below. So in the next triangle we have STU. Angle J, though, you'll notice has that little degree symbol, and so angle J corresponds with angle S. Therefore, I'll write angle S underneath angle J. And then I'm going to, under angle K, we know angle K is similar, or sorry, congruent to angle T. They are the exact same angle. So we make sure that we put the T under the K. And then we have under L, of course, the only remaining one is U. Okay, now we don't need to draw the grid, but that's how you want to line those up so that you have those triangles. And then we just say that triangle JKL is similar to triangle STU. And so again, vertically, we know that J and S correspond, K and T correspond, and L and U also correspond. All right, we have another diagram here. There are two triangles, and we're naming the similar triangles and write the letters so angles appear in corresponding order. So this time, you might want to try it on your own first. Pause the video and see if you get it the same. Can line that up on your own. Triangle, triangle, and kind of fill in the blanks here. You fill in the letters on your own. All right, so I'm going to start off with the first one. Doesn't really matter. I'll call it QRS. And what corresponds with Q? Well, I'm looking at this line here being parallel to this line here. I know that because of those symbols that we see. And so that tells me that, and you might remember this from elementary school, you have two parallel lines and a transversal. This line here is called the transversal. And when you have that, you end up getting what you know as the Z pattern. And the Z pattern, you'll recall, is also known as alternating angles. So therefore, if I do this Z right here, I get angle Q equal angle U. So I know that the Q, of course, lines up with angle U right here. R, by virtue of the same theory, R, if I do the Z this way, I have angle R equaling angle T. So that lines up. And of course, I'm only left with S. Of course, S lines up with S. That makes life a little bit easier. So just erase that. Okay, so we used alternating angles to define that. And then we know, of course, those two triangles are similar. Okay, because they're corresponding angles, as you see underlined in blue here, the corresponding angles are equal. Moving along, here we're going to show, this is different. This angle, this question here said name the similar triangle. Oops, name the similar triangles. It told us that they were similar. In this question here, it says show. Another word for show might be prove that the triangles below are similar. So in this case, how do we show / prove that the triangles are similar? Well, we go to our learning goals. The learning goals tell us that similar triangles have corresponding angles that are equal, and or you can prove by the fact that their ratios of corresponding sides are equal. So those are two methods. So method one, show corresponding angles are congruent. We're going to show that by angles. So something like we saw up here with this, except this time we actually have to prove it. We can't just name it and say, oh, look, they're similar. So we're going to say that angle Q is equal to angle U, and in brackets here we're gonna note alternating, right? Alternate angles. We'll just put alternate in brackets. So we're proving because they're alternate. Now I don't mind if you write alt, to be quite honest, so that you're not always writing 50,000 words. That's not an essay. So angle Q equal U, alternate angles. And by virtue of the same theory, we have angle R is equal to angle T by virtue of the same thing, alternate angles. Now I know I mentioned that above, but above I didn't have to mention that. I was just showing you that they're similar, but the question did tell us that the triangles were already similar. I was just showing you how to properly line those up. And because though we know now angle Q equal angle U and angle R equal angle T, because we know two angles and each of the triangles are equal, automatically this third angle here must equal each other. Just be aware of the fact that when you're naming this, if you wanted to call angle S, if you want to say angle S equal angle S, we can't necessarily just say that. And the reason why is because angle S could mean this angle outside here, or this angle here where the letter S is actually written. And we don't want to have any misconception. When I say angle R, there's no misunderstanding that I'm talking about that angle right there. If I say angle T, I'm talking about that angle right there. But R, there's some ambiguity. Sorry, with letter S, there's some ambiguity. So in that case, you'd have to label it angle QSR, for example, or you could say RSQ if you'd like. Okay, and then in the next triangle, you might have to call it. You might say it's equal to angle TSU, and you can just say OP P for opposite, because opposite angles are equal, but you have to have that letter S in the middle, and you have to define that angle specifically. So it's QSR, I'm talking about specifically that angle there, or TSU, and I'm talking about that angle specifically there. Hopefully that helps you. And the reason why I didn't do that first is because I find it a lot easier for us to just say angle Q equal angle U, angle R equal angle T. A lot less writing, and being a little bit of a mathematician, you want to make sure, usually you're a minimalist. We don't want to write essays here, like I said before. You just want to prove. So we're showing that those corresponding angles are congruent. Corresponding angles are congruent. We gave the reason why, and I could say, therefore, triangle QRS is similar to triangle UTS. Okay, because those angles are equal, the third angle is automatically equal because angles add up to 180. And we know that therefore those triangles are similar. Let's try this next one. Show ratios of corresponding sides are equal. In this case, we're going to actually name the triangles first. So let's call the first one triangle DEF. And then we're going to say triangle, actually, you know what? We don't even have to do that. Let's take a step back for a second. Let's just name the side lengths. I know that DE here, side length DE, no, I decided to go backwards. Let's go back for a second. Let's do that. Triangle DEF, we're used to this by now. So triangle DEF, and I'm going to line up angle DEF with the corresponding angles in triangle ABC or CAB or ACB, however you want to call this. But we're going to line up angle D lines up actually, if we were to flip this triangle, we would assume that that looks like a 90-degree angle. So angle A and E seem to be congruent. We don't know that. And we can say angle D seems like it's congruent to angle B, so I'll put B there. And of course, F and angle C seem to line up as well. So we can write that for now. We don't know that 100% sure, but what we could do, what this helps us do, is now I'm going to say, I'm going to split this up. I'm going to say DE, so line DE lines up with BA. Okay, so I'm going to write here DE in respect to, or it has a, in relation to AB, or we'll say BA, that's fine. And I'll say is equal to DE, we have 1.5, and BA or AB is 3 centimeters. So this really equals, if I reduce it, is really 1/2, right? Then we'll look at another corresponding side. Let's look at AC. Use a different color here. Let's look at, use purple. I'm looking at, let's do EF and AC, and they line up. So let's say EF over AC is equal to, and EF is 2 centimeters, and AC is 4 centimeters, and that also equal 1/2, right? And then we also have the last two, which would be DF and BC. So you can say DF to BC is equal to, and what is DF equal to? Is just E, which is unknown, and CB or BC is 5. So I don't know what E is, but I did show that the ratios of corresponding sides are equal, and this third one will automatically be equal. If these two are equal, then the third one is automatically in the same proportion. Hopefully that makes sense. So we've proved that, now we proved here that triangle DEF is similar to triangle BAC. So the nice thing of lining these up vertically is that I can automatically compare the side lengths, or the ratios of side lengths, because I have DE corresponds automatically to BA, and then you also have EF corresponds with AC, and then the third one is simply looking at DF and BC, and that's simply how it works. All right, hopefully that makes sense for you, and I don't think I have any other more questions here for you, and that's it. We'll see you in class. Welcome to trigonometry.